The table below shows the population of several countries in millions and the number of blue cars in each. Complete the table by computing the number of blue cars per capita, which really means the number of blue cars per person for each country. Express these in scientific notation rounded correctly to the hundredths place. Also, convert these values into the number of blue cars per 100,000 rounded correctly to the tenths place. I'm going to go through and we're going to do each country one at a time. So you might want to jot down some of these numbers for Countrystan, big country, small country, and another country. Those are our 4 countries that we are dealing with today. So we will start with Countrystan. And first we're going to find per capita. So remember that blue cars per capita. So remember we're going to put the blue cars on the top and we're going to put the people on the bottom. So for Countrystan, we've got 598 blue cars and we have 29.2 million people. Well, million implies 6 decimal places. So if we take this and move it 1, 2, 3, 4, 5, 6, we're going to be adding 5 zeros. So I'm going to take 598 divided by 29.2 with 5 zeros. And when I type that into my calculator automatically spits out at me scientific notation. And I end up with 2.05 times 10 to the negative 5th when I turn it into scientific notation rounded to the nearest hundredth as directed in the instructions. Now, that's per person. So if you think about this just for a conversation piece, in standard form, this is how many blue cars here in gray per person. That tells you nothing, right? I mean, you can't do anything with a number that small. So that's the purpose of the per 100,000 column, is that you can now have a number that you can actually comprehend. So right now we have this 2.05 times 10 to the 5th is out of 1. So 2.05 times 10 to the 5th over 1. And we want to say, how many would that be out of 100,000? This is the concept, right? And if you would cross multiply, you would get 1x, which is just x, equals 2.05 times 10 to the negative 5th times 100,000. So essentially, you're going to take the per capita and you're going to multiply by 100,000. And that will turn it into per 100,000. And when I do that, I end up with 2.05. And if we round that to the nearest tenth, I end up with 2.1 because this is 5 is what we're looking at, 5 rounds up. So out of 100,000, 2.1 will have blue cars. Out of 100,000 people, 2.1 of them will have blue cars. That seems really low, but hey, this is the made-up data we're dealing with. In big country has 2,912 blue cars and 256.8 million people. So again, we want to move this 6 places. 1, 2, 3, 4, 5, 6, which means we are adding 5 zeros. So I'm going to take 2912 divided by 2568. 1, 2, 3, 4, 5. And again, my answer, my calculator spits immediately into scientific notation. To the nearest hundredth, 1.13 times 10 to the negative 5th. So now when I want to go to 100,000, I take that answer and I multiply by 100,000, and I get 1.13. Well, tenths, 3 rounds down, so per 100 would just be 1.1. So in big country, we actually have a smaller per capita and a less per 100,000 in terms of blue cars. Okay, let's go to small country. And small country has 483 blue cars and 13.8 million. So that's 483 divided by 13.8 with 5 zeros. And it's 5 zeros, remember, because you got to go 6 places. And because that 8 is one of those places, I only need 6. So my calculator spits, and it comes out pretty nicely, 3.5 times 10 to the negative 5th. And it is 3.5, so that's kind of weird. So Because it comes out nicely, I know it says round to the nearest hundredth, but because it comes out nicely to a tenth, you would just leave it as 3.5. Now we need to go to 100,000. So I take this and I multiply by 100,000, and I end up with 3.5. And it's already in tenths, so I don't even have to round. It just comes out very nicely. All right, and the last one would be another country. So another country has 1,101 blue cars and 109.1 million people. So we have 1101 divided by 109, 1, 2, 3, 4, 5. Because again, 6 places for our million, and we end up to the nearest hundredth in scientific notation. Now, if your calculator gives you in standard form, you might have to go to scientific notation on your own. So if your calculator gave you 0.000101, you would have to naturally think, I need my decimal point to be after the 1. I have to move it 5 places. This is a super small number because it's less than 1. That makes me have a negative exponent. Right? You're going to have to work through those scientific notation problems like we did in Unit 2. Okay, and then we go to 100 per 100,000 by multiplying by 100,000, and I end up with 1.01 tenths. Look, 1 past, 1 rounds down, so I end up with 1.0. And that's it.